So just a reflection from yesterday, for those of you who were able to take part, we did hear from Dr. Ayanna Elizabeth Johnson, and I just wanted to send a quick curio forward to you all that I thought was great. She mentioned Elizabeth or Eunice Newton, who is a scientist Elizabeth Newton Foote, a scientist on the left, you see her pictured here. In 1856, Eunice published a paper that was so interesting and hit at such an inflection point for women in science. The paper was Circumstances Affecting the Heat of the Sun's Rays. It was presented in 1856, and it's considered one of the first works to describe global warming and the effect of CO2 as a heat trapping gas in our atmosphere. So here's a woman developing an understanding of the effects of CO2 burning in 1856. Due to being a woman in science, her work was not taken up by mainstream, the canon at the time. And so a lot of that possible inflection point that humanity could have gone through to absorb what she was bringing forward, that inflection point never fully operationalized itself in society at large. At the same time, the same year in 1856, the gentleman on the right, William Perkins, developed the first synthetic dye, taking 400 pounds of coal tar to make 1 ounce of dye. So it was supposed to be a malaria recipe or cure, and there was an explosion in his lab, and his lab walls turned this purple color called mauve. But it's interesting that how textile system research was moving into fossil carbon in 1856, while we had a woman scientist pointing to the issues of using that material and what it would do for generations in the future. So here we sit in this moment where the industry that we rely on to dress ourselves is still very entangled in the use of fossil carbon. And humanity is obviously working very quickly to find alternatives. But just framing this up, I thought this was an interesting moment, 1856. There's a lot going on in that critical juncture. Oh, I'm gonna go back to this. So for today, when we think about diverting the investment in fossil carbon fibers, fossil carbon dyes, and we think about transitioning to materials that have a decomposition pathway, as the Biomimicry Institute would say, how does nature take materials that we generate and turn it into food sources for the next generation of life? How do we create circularity on that microbial level, on that atmospheric soil carbon, ocean level? How do we keep things flowing healthfully? How do nutrient cycles flow healthfully? And right now we have so many materials that don't decompose. They don't have a decomposition pathway, and those are the plastic fibers, which we talked about yesterday. So when we say 65% approximately of the textiles we're wearing are from the lithosphere, we have a big amount of work to do to transition ourselves into biosphere-based materials. And we obviously are consuming too much. We have way more than we need. So if we reduce consumption, extend the use phase of our textiles, plus we make transitions to regenerative ag and natural fibers that can decompose, we still have this big nut to crack in how our fibers are grown and how our dyes are grown. And eutrophication is a term that some of you in the design schools might get exposed to. It's this metric that's used to define the impact of a natural fiber. Because when we grow on landscapes where we want high levels of productivity, since after World War II, we've been using chemistry to enhance the growth rate and yield of our fiber and food systems, to the detriment, though, of ecosystems. And so we have to think really carefully about if natural fibers, if land-based fibers are the transition, how are we growing them? What are the pathways to do this well? So eutrophication is a process whereby too much of a good thing, too much nitrogen, ends up in a riparian corridor, going out into an estuary, into a marine ecosystem, and these dead zones occur. And what happens is too much nutrient flow goes into the marine ecosystem. For instance, algae forms, the algae sinks to the bottom of that estuary or that bay, and microbes start to digest that material, and they eat up all the oxygen in the process. And so these dead zones become hypoxic. They become areas without enough oxygen. And you can be growing natural fibers and be contributing to this issue. So these dead zones, though, can be healed. That's the thing that's so important. We can't get plastic out of the ocean yet. We have not figured out how to do that, but we can heal dead zones. In fact, they heal on their own if left alone for long enough and no more runoff is put into the system. So just to frame up in the context of our Fibershed, where we're speaking from today, in California, we have about 2 million residents in California who have access to water that is not regulated by the state, and about 451 wells and 205 community water systems that have nitrate contamination. They have too much of this material that's been used on the surface contaminating the groundwater. And it's created approximately 2 million people are drinking from these water sources, but they say approximately 1 million people in California don't have access to clean drinking water. And nitrates are associated with thyroid disease, diabetes, and cancer. So it's a really serious issue if your groundwater gets contaminated with excess nutrients from the surface agricultural system. And remember, California, our Fibershed is producing 2/3 of the United States' fruits and nuts, 1/3 of the country's vegetables, and we're the largest Pima cotton producer in the United States. So it's extremely important that we continue to think about how to produce food, but produce it well, how to produce fiber, but produce it well, so that we are protecting communities' water sources. And I thought this last piece here, the slide on, or the map of California on the left, those green, that green part, that's the Central Valley. That's where all the food and fiber, or I'd say primarily a lot of food and fiber is produced in our state, in our Fibershed. And where you see the vision of California on the right, that's where you see all of this smog coming. They call it a nitrous oxide smog. And that is 41% of the smog from nitrous oxide sources is coming from agricultural soils. So we're applying quite a bit of nitrogen in the Central Valley, and the smog is coming from those places. But we also know that transitioning this land to housing or any other use that would develop this land would create 70 times the carbon footprint. So agriculture needs to just go through a transformation. We need these food producing and fiber producing landscapes again. So today, what we're going to do is hear from a woman scientist who's been doing a lot of research with an amazing community and team, of course, who has been understanding what are these pathways to transition so that we aren't creating eutrophication in the marine ecosystem, so that we aren't contaminating our groundwater with nitrates, and we aren't creating nitrous oxide smog. These are all issues that we have to contend with in the natural fiber conversation. And so I wanted to have today's symposium day be about solutions to core issues as we make these bigger transitions societally. So just as a reminder, these are the two panels. Again, if you stay on this track, Black Fiber Systems is the track you will be on, and then we will continue the water and soil conversation with a panel that will run concurrently, and you'll have a link in the chat. So I'm going to introduce Dr. Daley. I'm going to stop sharing my screen. Oh, thank you. All right. Thanks, everybody. So Dr. Daley is a colleague and friend. Thank you so much for taking time to be with us today here virtually. And then her bio is wonderful. So I'm going to take just a moment for that. Dr. Cynthia Daley is a professor within the College of Agriculture at California State University of Chico, and currently serves as the Rawlins Endowed Professor for Environmental Literacy and the Director for the Center for Regenerative Agriculture and Resilient Systems. This new Center for Regenerative Ag and Resilient Systems is a consortium of interdisciplinary faculty and farmers who recognize the ecological benefits of regenerative farming practices, including water conservation and soil fertility and carbon sequestration. the center's guiding principles is that agriculture, when done regeneratively, can be the solution to soil degradation and climate change.
Excellent. I love it. Rebecca, I can't say how pleased I am to be invited to be here today with the group. And I'll just do a real quick sound check. Can you hear me okay? Is it coming through all right?
Sounds good.
Beautiful.
To me. Yeah.
Okay, good, good, good. Well, yes, I am such a big fan of Fibershed and all the great work that Rebecca and her team does. There's so many opportunities for us to work together. I'm really pleased about that. So, and I think it's great that we're seeing so many wonderful, capable, competent women leaders in this area of regenerative agriculture. I'm just pleased and honored, to know Rebecca and the work that she's doing here is very impactful. So happy to be here. And what I'm going to talk about today is about how we go about changing our agricultural practices to reduce this nitrogen pollution. I think Rebecca has done a fantastic job really outlining the issues. So I'm going to move through that portion of my talk pretty quickly. But, suffice it to say, we've been using fertilizers for a very long time. Back since, the 1900s, when, the process of Haber-Bosch was just first discovered and then applied into a fertilizer type of a situation, we have seen an increasing use of that really since the 1900s. So we've got an addiction to nitrogen fertilization, and that increase in nitrogen use has really mirrored the increase in our population globally. So frankly, half of our global population is really propped up with the synthetic nitrogen fertilizer addiction that we have. So, there is that we need to consider. The unintended consequence that's associated with fertilizer use is the fact that only half of what we actually apply is utilized by the plant. And that, to me shows a pretty significant inefficiency in the system, because the other half is the problem. The other half is going into the system either through nitrification, denitrification, leaching, or volatilization into a greenhouse gas.
Cindy,
that is creating.
Sorry.
Yes.
Do you mind doing full screen?
Oh, I can certainly do that. Is that better?
Is that better, everybody?
Perfect.
All right.
Okay.
Sorry, go ahead.
Great. Hey, appreciate that. Good. So ultimately, the fate of that fertilizer is problematic, and so we've got this huge issue with greenhouse gas that is creating the climate change, the climate crisis issue. So it's part of the problem and something that needs to be addressed. Rebecca's already talked about, these dead zones that are being created from the leaching and the eutrophication that's taking place, and most of that is really coming from production agriculture. There's 405, I'm so glad our statistics match, Rebecca, so that worked out really well. Around 405 of these dead zones around the globe, with more in the works. You can see the yellow dots there are ecosystems that are fragile, that are on the brink of having some, breakdown. 95,000 square miles. So this is a significant problem, one that seems to continue to get bigger. The Mississippi River Basin that feeds the Gulf of Mexico is 1.2 million square miles. So it's huge. It's 40% of the lower 48 states. And a majority of this nitrogen and a majority of the nutrients that are leaching into that system are really coming from production agriculture. Not all, but most. Certainly we can do better. And in studying this problem, we have learned, that there are ways that we could sort of contain this issue. The different production systems basically feed into the system at different rates. Conventional system, which is the predominant system of production agriculture, is the major contributor to nitrate leaching into our waterways. Followed by even a no-till system in an annual cropping system still makes a contribution, but as you can see here, significantly less nitrate nitrogen. So just by switching to a no-till practice, we significantly drop the amount of nitrates that are leaching into our waterways. A reduced input or a biologically based significantly reduces the amount of nitrate that's being lost into the system. Perennial cropping systems are even better. So clearly, how we farm matters. It's really gotten to be a real problem here in the Central Valley. And you know, this is the belt of incredible diversity in production agriculture. There's 250, 260 different types of crops that are grown in this. We are just a literal cornucopia of food and produce. But we've got a real problem. Everywhere you see red zones, you know, that's a serious infraction from a regional water quality control board perspective. And if it's not addressed, they're looking at about a $3 billion a year cost to our social infrastructure in the valley because of this nitrate leaching problem. I mean, there are communities in this area that cannot drink their own water. And so they have to exist on bottled water, and they are living in areas too that economically can't really afford health care. So it's a double whammy for those people. And it's not just California, even though we have our share of problems. It's a nationwide problem. It's a global issue where we're seeing real issues with our aquifer system is just filling up with higher and higher levels of nitrate. And Rebecca's already talked about the health implications there, but you know, a new study is also very, very frightening to me because it's not just nitrate, but it's what the nitrate is bringing along with it. There's a new study out that shows that as the nitrate levels rise in our aquifer, it's also leading to the leaching of uranium into the waterways. And that's very bad for bones and kidneys. So, hey, we've got a problem. So we really need to deal with that. And unfortunately, production agriculture is not really great at, at claiming their problems. So we work really hard at that. You know, this is my family. I consider agriculture my people, born and raised in production agriculture. My folks and family still farm in the Midwest in Illinois, in the heart of the corn and soy country. And we need to embrace this and accept it and then work to find solutions. And to some degree, that is in fact happening because we are seeing a drop in the amount of fertilization use. And that comes with learning more about application rates. We've learned a little bit about formulations of different fertilizers to eliminate some of the negative, drawbacks. The timing of application, and from where I'm from, a lot of producers still like to do a fall application of fertilizer. And it's a ridiculous approach because that fertilizer, for the most part, is lost to the environment. Because you go into a nice, winter system, nothing's growing. So there certainly isn't any plant uptake. And a lot of that nitrogen can be lost pretty rapidly. So it's changing the timing of the application. It's also changing the placement of the fertilizer application. We now have some precision delivery mechanisms where that fertilizer is actually injected, right into that root zone or right into the seed area. And it's making us a little more nitrogen efficient. So from that perspective, you can see over in this particular chart, this chart looks at the amount of fertilizer, seed, and pesticides on a per acre basis that's being spent in my homeland in central Illinois. And you can see over the course of the last 5 years or so, there is a steady decline in the amount of fertilizer that's being utilized. So we need to look at this as a win. It's an indication that we're recognizing the problem and that we're becoming more fertilizer efficient. So I think that's a really good thing.
Dr. Daley,
yes.
Sorry, just to interrupt. Would you just mind pulling your mic down just a little bit? Just pull it down a little bit. Yeah, no, just down. Yeah, perfect. And just say something for me quickly.
Down like that. So how
yeah,
does
that's perfect. Thank you. We're just getting a little popping. That's perfect. Great. Thank you so much.
Okay, good. Well, I guess Madonna isn't threatened anytime soon. I think I just didn't have my Madonna on today. So sorry about that. This slide looks at net income on the farm. And you can see that if you look at the net profit or the net farm income over time, over the last 20 years, it really hasn't changed all that significant. So farm costs go up and farm income is pretty flat, and to the point where most farmers today are really looking for an off-site source of income. Most of the spouses or teachers, or they're doing something else off farm in order to bring more on farm income, which is really sad for me to see that situation. The farm situation also is, that we're in debt. It's been a long time, since the 1980s, where we've had this much debt overall. And if you remember what happened in the 1980s, it was pretty ugly. When interest rates did rise, we lost a lot of farms. We had a lot of bankruptcies. We had a lot of suicides. And I guess why I'm pointing this out is that we're kind of at that brink now as well. And we don't want to lose our farmers. We don't want to lose them. We don't want them to be displaced from the farm. We just need to transition into a new form of production agriculture. And I brought this slide because I just like to remind everyone that the fertilizer companies are alive and well, and they're doing quite well, even though the farming communities and the farmers are not economically as viable as they might be. And we've got kind of an interesting situation going on right now in the fertilizer industry, is that because we have seen kind of a pullback from the amount of fertilizer that's being used, we have plenty of supply, and it's causing a drop in price. So, we're just going to hope that producers don't see that as a signal to use more fertilizer because it happens to be more economical and they can get, more bang for their buck, that kind of a thing. So we really need a new way of thinking. We need a new form of production agriculture to address, the big issues that we have here today. And I'm going to quote another iconic individual, someone who I have a great deal of respect for, Dr. David Johnson, who's a soil ecologist with New Mexico State University. He's also an adjunct professor for the Center for Regenerative Agriculture at Chico. He said, to find a solution to this problem, it may be time to explore how nature has solved this problem. Nature is able to fix sufficient nitrogen from the atmosphere with a very diverse community of microbes in the soil microbiome to support production. And we're talking about a lot of production, more production than most of our farming community, more than some of our farming production systems produce. So we need to mimic nature. And this is where I'm going to introduce regenerative agriculture. And I know many of you on this call are familiar with this particular topic, but this is the form of agriculture that can really address this issue of nitrate leaching and groundwater contamination and greenhouse gas emissions, and the fact that agriculture is part of the problem where it could be part of the solution. So regenerative agriculture describes farming and grazing practices that, among other benefits, reverse climate change by rebuilding our soil organic matter and restore degraded soil and biological diversity. So that results in carbon drawdown and improved water cycle. I mean, it's a perfect solution, and it's a new way of thinking. It's the difference between what you see on your left, which, believe it or not, some people think is a beautiful thing. I mean, you can ask my brother and he would probably tell you that looks very, very nice. And we do have a lot of recreational tillage out there. Let's face it, farmers love their tractors, and the bigger the better. And we have some really big tractors out there. And it is pretty powerful sitting in that cab, driving that with your stereo system and your air conditioner. Farming's not what it used to be. My sister is actually knitting for her grandkids as she's driving her tractor, which is driven by a satellite. The only thing she has to do is turn it around when it gets to the end of the field. Anyway, it's a very different system. In that system, you disturb the soil. You just beat it. You beat it into submission. That's the approach. It's manhandling Mother Nature. It's monoculture. It's reductionist. And we went monoculture because we became specialists. We can do a much better job if we're only doing this one thing. But it's so different than what nature. would try to create. So regenerative agriculture is like the polar opposite of that. Here we're trying to partner with nature. We're going to protect the soil. We're going to build diversity. And we're really going to look at farming from a holistic perspective. We're looking at the big picture. Big differences, obviously. Regenerative, part of the solution. Conventional, it's part of the problem. 5 principles really to minimize disturbance, maximize crop diversity, keep that soil covered, maintain a living root, and integrate livestock. And what we get by paying attention to those 5 principles is a much better soil health. We're going to improve diversity, and we're really going to improve the water use efficiency of our farms and the economic resiliency. It's a win-win-win. And I get this question a lot, so I'm just going to throw it out there. I was born into the sustainable ag movement, and I think that it has done a lot for production agriculture, but frankly, our systems are degraded. We don't want to sustain a degraded system. Hey, we have to regenerate them. We have to rebuild them. And it's going to have to be from a change in the way we perceive agriculture. We need to move away from this being the beautiful thing to this on the right side. That chaos, that's a beautiful thing. That's diverse, that's alive, that's resilient, it's nutrient dense. It's everything that we need to move toward. What's on the left is a net carbon emitter, a net nitrogen leacher. This is not a positive thing. Same kind of a scenario, but over in a row cropping system. The left is recreational tillage. We're going to beat it into submission. And on the right, we're going to keep that soil covered. We're going to keep a living root. We're going to work very hard at diversity on the soil and in the soil. We're going to apply those 5 basic principles. And so it is polar opposites when you really look at it. One is more of a systems, going towards a natural type of an ecological system that does become a closed system over time because you don't need the inputs. It's going to be a self-sustaining system, as opposed to our input consciousness, geochemical approach to our traditional conventional agriculture. The relative benefits have already been calculated and well published. The overall benefits to society, obviously, if we were to adopt this regenerative farming practices, a lot, less global warming. We're going to see less pesticide risk because the biological diversity is not going to allow the niche for pathogens to take hold. There's going to be less phosphorus runoff, less nitrate leaching. There's going to be more soil conservation because there's less soil erosion. And more soil organic matter means we're going to be more water efficient. Keep in mind, for every 1% increase in soil organic matter, we improve our water holding capacity by 20,000 gallons per acre. It's remarkable. And what I love about this slide, everybody knows Gabe. This is Gabe's transitional slide. This is his learning curve over time in the regenerative paradigm. And so obviously it doesn't happen overnight. It takes time. And so as Gabe accumulated knowledge and trial and errored these new techniques, he got to the point where he was at 3% soil organic matter. And at that point, that was like the magic number, when his soil became a biological engine and he no longer needed fertilization. So at that point in time, he stopped adding his fertilizers. At that point in time, he stopped with his emissions and his leaching and his other and the cost. He became much more economically viable, which I think is fascinating slide. And it's because of this. It's because of the biological diversity that he built in his soil. And it's just that difference from the monoculture, where you only have the one crop trying to feed that one group of organisms. So it comes to this term called quorum sensing. And that's where we actually have this cell-to-cell communication going on in the soil, where all of these start working together. So it's not the one organism. It's not just this one bug in the jug. It's a whole group of organisms that are really important in terms of their communication with each other and with the plants and the plant roots in the soil. Goodness, let me see if I can get rid of that. So among this very diverse community, we have free living nitrogen fixing bacteria, and they're able to, pull from the atmospheric nitrogen and fix it and make it available to plants. Rather than having to apply it. And in fact, if you apply it, you're actually going to inhibit these organisms. So, all these years, us adding fertilizer into our soil systems was actually shooting ourselves in the foot, where we were shutting down the natural biological system that was designed to feed the plant the nitrogen that it needs. So, this is a whole paradigm shift for all of us, not just farming community, but the whole research community has to get their mind around this. This is just a new way of thinking. Okay. Let me see if I can get this to go. Oh, there we go. And another aspect of the interaction that takes place here that we just didn't realize was the fact that, the soil, being a live organism, is also very, very rich in fungal species. And these fungal species are vitally important. They actually become part of the root tip. And, as part of that root structure, they also turn on new genes in the plant itself, in the plant. And this has got a real positive effect on plant growth physiology. These are all things that we just didn't know. And this all comes from mimicking nature, from doing the biological type thing. This is a real nice close-up, so you can kind of see the thread-like filaments of the hyphae from the mycorrhizae, and they secrete this beautiful coat of glomalin that helps sequester carbon, but also creates the glue in the soil structure to give these aggregates a very stable structure. So rather than being lost with the first rain, or there's structure to the soil, and it's being held there because of the glue that's being produced by this biological diversity. I mean, it's an amazing thing. So, this is really what we want to look for, this beautiful porosity with, life oozing from this soil. That's a regenerative farm. I can just tell it by looking at that handful of soil. And I did want to touch on a new project that is the next step of the many projects that Dr. David Johnson and his wife Wei Chen have been conducting in New Mexico State. And all of this work is really based on developing this biological diversity, to develop this quorum sensing type community within the soil structure itself. And the way in which David and Wei Chen have done that is by developing a inoculum through the use of these composting bioreactors. And they call this system the biologically enhanced ag management system. So it's not just the inoculum, but you have to create the inoculum in order to add it to the biological system and the soil and the no-till and the cover crops and everything. You need to layer all of these production practices together in this regenerative system in order to get it to hum. The beauty of this is that it's an aerobic composting system, and it does take 12 months to produce the biological diversity, but the metagenomic analysis of this material shows that it's got like 2,600 different species. So it's very, very diverse. We're not talking about any one organism or two organisms. It's that whole biological diversity that will ultimately be working together in a symphony, so to speak. So this is some preliminary data that we're pretty excited about. This is a conventional corn bean rotation where we're looking at 3 different treatments that have been replicated in this conventional farm system at scale. So these aren't just small plots. where we've got a conventional, so this is the normal production system where we're applying 256 units of nitrogen. Then we've got another replicated treatment where we've got the beam, which is this biological inoculum, together with cover crops and no-till, and 15% of the original fertilizer. And then we have finally the third treatment, which is beam alone without any additional fertilizer whatsoever. This is called cold turkey, and it sends a cold shiver up most producers' spine just thinking about going through that fertilizer withdrawal. I mean, I've seen it time and time again. I get it. I mean, I do. I get it. You have so much at stake. It's understandable. When you look at the amount of nitrogen that's removed and the amount of residual nitrogen left in that system based on the amount that's removed with the crop, I mean, we're looking at the fact that we lost 126 units of nitrogen to the atmosphere in this conventional system, where we didn't in these other two systems, which is pretty exciting. And when you look at the economics, the conventional system, you know, based on production, and of course, there's going to be more expenses here because we do have to pay for fertilizer. So the reduction in overall cost per acre here in these other two treatments is realized through a reduction in the amount of fertilizer that was purchased and applied in those systems. Increased revenue per acre, the highest was the beam plus 15% nitrogen at an additional $121.59 per acre. The beam itself with no fertilizer, where you stressed and you probably lost a lot of sleep because you didn't add any fertilizer at all to this crop, actually yielded an additional $86.19. It was not the highest yielding, but it was more profitable than your conventional approach, if that makes sense. So in conclusion, the biologically enhanced production system negated the need for fertilizer inputs over time. Even the farmer that, you know, is our co-investigator in this project kind of walked out there and said, why am I applying all this fertilizer? Which is, a light went on, which is pretty exciting in and of itself. The biologically enhanced system really improved the biological diversity. This study goes on for another 2 years, and you know, it'd be great if we continue it on from there, but we do have funding for 3 years. We're going to look at the need for pesticide, look at pest, weed infiltration, and so on. It improves water holding capacity, and it improves the return per acre by reducing the amount of input costs. So that's a pretty exciting outcome for year one data. And we're also experimenting now in alfalfa and in cotton together with Rebecca and the great work that she's doing with guest genes. We're also in rangeland, which is going to be very interesting to see how that comes together. We've got 6 sites where we're looking at the effect that this has, you know, on a rangeland ecosystem as well. So be looking for this information. I'm hopeful that we'll have some data for everyone real soon. And with that, I think I'm going to go ahead and just open it up with questions, if anybody might have some. I'm going to stop my share.
Cindy, that was amazing. Such an efficient cascade of pertinent and wonderful data. Thank you.
So that was the plan.
Well done. So there are questions, and people have voted on a few that have, let's see, I'm going to start with, so yeah, I think Hope, this woman, Hope Salzer, is referring to the image that I showed of California. Are there, in the green areas in the Central Valley, are there areas where organic agriculture is practiced? And I mean, off the top of my head, I could say yes. It's just not maybe as predominant by any stretch of the imagination, but it's there. Would you agree?
I would agree with that. Yeah, we do have some certified ground. I don't know the exact number in California, but I think, you know, throughout the U.S., we're at about 1.4% of the production ag ground is certified as organic, and certainly that does have an effect on the amount of pesticide and other types of things leaching into the groundwater as well. But we do see a lot of commercial organic systems that are still in love with their tillage, and that's the unfortunate piece where the organic thing is. And I've been involved in organic since 2006, so I'm very, very familiar with the process. And we're hoping that we can kind of transition some of those that do tillage, into a no-till kind of a production system. But they certainly have the leg up on everything else. I mean, organic does the composting and the mulching and cover crops. They do really they do a lot of things very, very well, as you know.
Yes, yes. Yeah, I mean, we're all huge fans of increasing organically managed acreage, and while also supporting this, the soil texture, protection of soil texture. It's so important for water holding capacity. And during our rain events, we really need in California to capture water in our soil and produce and surface water flow and aquifer recharge. And so
Yes.
it's
Yes.
truly important that we enhance our conversation around the whole process of managing these soil systems. So there's another question from Tuna. It says, the geochemical approach has huge corporations and business who have invested and who have a lot to lose. A natural humming system using nature's own magic doesn't pay for a chemical industry, which is now seeing its existence being threatened. Are you seeing power structures trying to do whatever it takes to stem this 180-degree change?
Yeah, clearly, they're involved in all of our well, not all of them. They're involved in a lot of that, where they try to promote their product because that's a good business plan. And let's face it, the whole the whole addiction that we have to fertilizer is a great business plan for them, because as you kill off your soil biology, you have to use more and more and more in order to get that same yield. And so it's a marvelous business plan. So I guess if they're looking for a place to invest, that's probably but ultimately, we need to make that transition. And I think that those businesses are going to move on to other, really positive corporate structure incomes that I hope will, satisfy their stakeholders, their shareholders, and so on. But those of us in production agriculture, this is just a no-brainer for us. We really need to go down this path. We need to go down this path for us, for our rural communities, for our farming infrastructure, for our farming families, for society as a whole. We need to go down this path, because literally we could become the solution to climate and to these issues with nitrate leaching into our groundwater system. I mean, we just have to change those things.
Agreed. And here's another question that's gotten a lot of support. What is being done to change what is subsidized in the USA to encourage and support large-scale farmers to switch over to regenerative methods of farming?
Well, that's a really, really good point, because, the Farm Bill is really designed to help us do that. And unfortunately, because of the lobbyists in Washington, we're not seeing as much funding going down that path as we need it to. It's still subsidizing a lot of commodity-based agriculture. A lot of companies, still need that corn fructose corn syrup in order to, make a profit. So we're going to continue to have that. That's going to always be a part of the Washington, D.C. structure. But I'm seeing glimmers of hope in other things. We're seeing more funding get into NRCS, into the conservation programs, and the EQIP program, Environmental Quality Incentive Program. That's good. It's got problems. We need some things that we have to fix there, but it's there, and it's providing a support structure to help offset some of the financial risk associated with embracing some of these production practices. Because face it, as a producer, if you're up against it all the time, you don't want to experiment. You don't want to rock the boat. You've got to pay the mortgage. You've got kids that need to go to college. So there's a lot of risk associated with that. So I don't want anybody thinking that this is, something that we need to put on farmers. we need to help them see the benefit. We need to help remove some of the risk of making that transition. And I think we've got some really incredible farmer mentors out there that can really help some of these farmers understand, what it can be like on the other side of that transition. And so that's been our job, is to try and elevate those voices, and to elevate our own farmer heroes that are really getting the job done and doing great work out there. And yeah, California Department of Food and Agriculture. I'm going to go ahead and plug our California Department of Food and Ag and the Soil Health Initiative. I mean, they put almost 28 million, Rebecca, was it 28 million into that last
year.
round? Yeah, of soil health initiatives, which were actually more incentive for producers to go into regenerative production than even the EQIP funding. And that's been a little bit of an issue between our federal and state dollars, but frankly, I'm glad the competition is there and we need more of it. So Gavin, if you're listening, we need more funding in CDFA HSI. Don't short us there. We're going to solve climate change if you just keep it up.
Agreed. And then there's also at the county level some efforts with climate action planning that happens at a local level. Mm-hmm. So this idea that we could see agriculture as a place to invest in if there's a development in a county that has an emissions signature, like a hospital or whatever, freeway extension is being done, then you could use offset dollars to at least invest in ag at a very local level. So it doesn't get involved in this bigger global carbon trading, carbon as an asset that can be traded, which is dangerous, I think, in some ways for the climate. But local ways to know you're going to have an emissions scenario through building something and then putting extra dollars into the land around the development is one thing we're seeing. Yeah, so that's happening county to county, slowly but surely.
I love it. I love it. And we need a lot of that, so everybody doing their part, all hands on deck.
Oh, and here's a question that you've answered in different ways throughout the presentation and through the answers you've provided to questions already, but just to kind of encapsulate this, what do you think the biggest barriers are for conventional farmers to start working with the 5 principles of regenerative agriculture?
Yeah, it's here. It's how we choose to perceive it. It's what we've always done. It's what my dad did or my mother did. It's kind of the culture of agriculture that is our stumbling block, more than I think anything else. You don't want to be the talk of the coffee shop in any farming community. Let's face it, that is a real problem. That's a problem. And so my hats are off to all of those innovators, those regenerators that are out there that have been doing this now for 10 years. They're reaping the economic benefits, but they're also, I think, they're getting some of that gratification as well. It was worth all that pain of enduring the being shunned at the coffee shop in order to, develop a real legacy for their family in their soil. So yeah, I just can't say enough about those individuals to be able to buck the system and make it happen.
And the Center for Regenerative Ag and Resilient Systems is holding up farmer transitions and farmers taking risks. And you've been elevating them. They're on your leadership council. I'm thinking of, is it Scott Park? And
Absolutely.
There's this way of celebrating when people take a risk, see a successful outcome, and then we celebrate them. We affirm the good when it happens with one another, even if it's a step that isn't look like, at least in the textile realm, a lot of the textile realm is driven by, let's just see them certified organic right away, or we want, and I understand the motivations coming from the market to be able to market things, but we also have a whole network of people involved in the production of any one textile, t-shirt, jeans. And there's these cultural conditions that encapsulate each part of the supply network. And in the farming community, I think you've really described for people today what the cultural aspects and the constraints and opportunities of that community. And if the brand community could keep resensitizing itself to being a partner in this journey for the farmer, I think
Right.
we're on a journey together. If we can hold hands across the supply chain, across the supply network, to be sensitive to where each other is at, we can start making changes as a team, which is kind of a theme we've been playing with. It's like
Right on.
building leadership across the supply chains, across the networks.
I agree with that completely. And I love the work that you're doing, Rebecca, along those lines. I think you do it better than anybody I've seen. So that's an amazing approach. On our website, you'll see that there are 15 farmers that we've identified and showcased and created case statements for. And we're tracking that, based on the number of hits. And frankly, David's work and Wei Chen's work with the bioreactors is one of the hot traffic areas, but it's the farmers on our demo sites that are really getting a lot of traffic there, because this is a great way for farmers to kind of kick the tire and see what's going on, and then they can dig a little bit deeper into that particular production system. And we've got mentor farmers across all production systems, so we've got grazing systems and orchard systems, row cropping kinds of system. Anyway, so it applies to every system, and it applies in every region. So this isn't a particular soil type. It's not a particular production system. It's all of agriculture can fall under these 5 principles. And if they're applied appropriately, and there's going to be some give and take, and there's going to be some good and bad. And I think what Gabe says, that if he's not failing at something at least one time a year, he's not trying hard enough. And I think we all need to take, we need to take Gabe's approach. He's quite an icon. And there are many, many more out there and in our region. So would love to have you reach out to some of those if you have any interest at all in this. We're more than happy to work with you. We're kind of blown away by the amount of interest we have in our graduate program. We've got six new graduate students on board. And we're looking at 4 more. So we're probably by spring, we should be in that 10 graduate student realm. So just think of all that energy that's going to be involved in this system, and working together with farmers, because we pair them up with a particular research project. And anyway, you've got yours, Rebecca, you've got Matt. So that'll be fun. Yeah, he's looking forward to it too. It's just
thrilled. And so maybe share with the audience, 2 things. One is there's, I think that the way you've designed the program is to get out there beyond the choir of who's already doing organic practice and who's, stacked reducing soil disturbance on organic practice, and there's all these configurations of ag we see in our community that are doing great things. One question came in, how do we get this out beyond the choir? And I actually think that goes to the heart of why you started the center, in a way to actually make a dent in who is actually consulting the agricultural community. Right now, consultation, you want to speak more to what some of the dream and the vision was around the center, get beyond the choir.
Right. Absolutely. Yeah. That was the thing that, some people have criticized us for not just being regenerative organic, and frankly, we all love organic. But that is a word that doesn't necessarily play well with the rest of production agriculture, the other 98% of the production acres, the other, group of farmers that are out there. And we want to build bridges, and we want to meet farmers where they are and help them see what they might do. So, I see regenerative agriculture as the gateway to organic anyway. And so it's like a gateway drug to get us going down that path. And you don't necessarily need to become organic. You just end up reducing the amount of inputs because you just don't need them once you get your biological system going. So that's kind of the key. And That's a real good indication of, if you're truly a regenerative type farmer, is that you've built up the biological aspects of your farm or your ranch, and you can kind of see it. It's real obvious. You just take the shovel out there and turn some soil over, and it will jump out at you, whether you've got enough, biological diversity happening in your soil profile. So yeah, we do want to try and reach out and bring in as many people. And some people are willing to try a few cover crops. Some are very adventurous and are willing to jump into no-till, which is a process. That is a real commitment. I know some producers that have actually sold their disc and plow and bought a no-till drill, and so that's a real commitment to going no-till. At that point in time, you don't have options. But ultimately, it's a transition for your soil. It's not like that's going to happen overnight. And, it really depends on, how bad your soil is as to how long it'll take for it to restore. And although I don't have any data, it looks pretty conclusive to me based on what's going on there in the industry. The more practices that you stack, the quicker the soil recovery, and you can begin enjoying that biological diversity. And by that, I mean, you just don't have to spend as much money on input costs, and you allow nature to do her thing while you're producing food and fiber.
And how many acres, does the center have any data on the acres that you've seen moving into these practices, the stacked function? Do we know yet? There's a question about
We don't.
acreage.
That's a really good question. And that's what we probably ought to put a couple of these new graduate students on, is kind of doing some of that survey work to get an assessment of total acreage. I know that there are some organizations out there that have a commitment to several million, which is exciting for me. And I really hope that all of that comes to fruition, because that's the kind of scale that we need in order to make a real dent in climate.
Yeah, I think, and watching the change happen, again, affirming good work where it's being done and showing that over time we are making change, that it's not all just agriculture as villain, which is kind of this
Right.
consistent, more media driven narrative. That is, got to work on that. So real quickly, we have the choir question, which again, a lot of what I've heard about the Center for Regenerative Ag and Resilient Systems core value is to get these grad students out on the landscape to support when the farmer has these questions. A lot of questions are answered by PCAs, pesticide consultants, or consultants that have been very well educated and schooled in their particular genre of ag. And as we develop these new understandings of soil health and soil biology, who do we lift up to get out onto the landscape to support the process of transformation? So you're graduating people who can get out there and do that.
Exactly. Yeah, that is actually one aspect of it, is to really kind of create those individuals that really get that, and that they can then go to work for a lot of these organizations that do have, advisors out on the ground. We're also developing a technical service provider training program that we're hoping to get, through the funding process. We're partnering together with the RCDs, some of our regional
resource conservation districts.
Resource conservation districts. We're already working with Candy at the Glenn County RCD, working with our state specialists at NRCS, working together with some of our other institutional colleagues at UC Cooperative Extension, working together with folks like, Rebecca at Fibershed, who has a very big impact. It's those kinds of partnerships and collaborations that will help us train these technical service providers to get them out there. We do train a lot of PCAs and CCAs at the university, and it's my goal to give them this regenerative perspective and this regenerative foundation, so that when they go out into the industry working for some of these companies that are really trying to provide the kinds of inputs that producers are looking for, that they'll be able to provide additional beyond the input consciousness. They'd be able to also provide the biological consciousness if they can find a match, with a producer that's willing to embrace that kind of an approach. So that, I think, is going to be a big important. And we're also partnering, with Regen Ag, Eco Agriculture, John Kemp's group. He's got a very big following back east, does a great job with his consultancy. He's developing some educational tools. We're trying to figure out how we utilize his platform for farmer to farmer networking, which we know is really critical in order to assist farmers through that transition period. It's the same kind of thing that our Jeff Mitchell has kind of put together with our collaborative tools with our CIG farmers, with our no-till veg production system, but it's on a national scale. So he's just launching that. If you know,
And what
that's
is
something
his
that
name again? Someone.
John Kemp.
John Kemp.
And I will, before the end of this, I'll put the link for his network into that. John Kemp, and it's Eco Ag. He's going to kill me for not having harvest. He's going to kill me for knowing
Oh,
it.
someone, Robin Mitchell, thank you, just put his
Perfect.
link, I think. Is it advancing? Yeah, advancingecoag.com.
The name of the network is something harvest. So John, I wish you were watching this, John. And I will put it in. I'll put it into the chat there. But I think that's going to be another wonderful tool where we're partnering together with other farmers. John's a farmer, but he's also a consultant. He's brilliant. He's written some books on the subject of soil health and how to create that in a more biological consciousness kind of a thing. And understanding agriculture, clearly, what Ray Archuleta, Gabe Brown, Alan Williams, and their team has done, I think is really outstanding. That's outstanding work that they're doing to kind of help farmers make that bridge. So it's putting everybody together. We're on the same team.
Agreed. And here's a question about some of the changes. So as I think it's Chris Radcliffe asks, have you experienced that drought and other effects of climate change are encouraging farmers to be more willing to adopt these new ideas? Or does it make them more conservative in their willingness to try a new idea when the impacts of climate change are bearing down?
Right. Yeah. It's an unfortunate thing. It's not always this way, but it's an unfortunate thing that when you're finally economically strapped, and in many situations, drought can have that effect on you. If you go through 3 or 4 years of a pretty significant drought, and if you've got a winter forage or a winter wheat, I mean, that has a big impact on your bottom line. That's the kind of thing that stimulates a paradigm shift in the human psyche. I wish it were different than that. It would be great if it, would just kind of happen because, by association with another farmer or another, paradigm, you were able to make that shift. But I would have to agree with that contribution is that I think climate change is driving people more toward, this approach because we are building more capacity for the soil to hold water. And it's starting to show. 2 years ago, we had a really wet spring. Do you remember that? It was raining so much in the Midwest. They were planting corn like in July. It was craziness trying to go with a really short.
We lost 19 million acres of grain and production.
Craziness.
Yeah.
And the no-till guys were out there getting that, getting things planted. Whereas the full tillage guys, they were sinking to the ground, and those were those horrible YouTube pictures. Those poor guys up to their axles, they were up to their cab. I have no idea how they get the mud out of their engines, but those were horrific photos, and my heart goes out to them. I mean, they had to get a crop in the ground. I mean, a lot of those people are in debt. They have to service their debt. They have to get a crop in the ground. So every year, it's a battle. It's a battle. And now that we've got these huge swings in weather, it's becoming more and more difficult, to get the same thing done.
Yeah. Well, thank you. We just ended at perfect time with that last question. Beautifully done. So grateful for your time here today, Cindy.